Good day. I'm George van Zyl from the Noordwes-universiteit Potchefstroom campus Agriculture Subject Group. Today we are going to show you how to choose the correct crop for your land. So let's say you have a piece of land such as this, which you would like to do some crop cultivation on. How do you choose which crop is suitable? So you first have to look at the climate and then the soil and then decide on a crop. And once you have decided on a crop, you need to do the correct cultivation, fertilization and irrigation to ensure success of your cultivated crop. So the most important factor to consider when choosing a crop is of course the climate, because that determines in which weather conditions your crop would grow. Monre Belili will show us how the different components of a weather station works, as well as which factors to consider when planting a crop in Potchefstroom with our specific climate.
Climate is a primary determinant of agricultural productivity, which is essential for sustaining and enhancing human welfare. Changes in climate can have a significant impact on crop yields and their nutritional value. And this means that farmers have to continuously adapt to changing weather patterns such as droughts and other climate-related risks in order to meet increases in the demand for food. A weather station is a facility with instruments and equipment to monitor atmospheric conditions, to provide information for weather forecasts, and to study the weather and climate. By studying the changes in atmospheric conditions, farmers can use the data collected by weather stations to make informed decisions about crops and their livestock. This, for instance, is a ClimaView 50 all-in-one multi-sensor, which is able to monitor, amongst others, solar radiation, relative humidity, precipitation, and wind speed and wind direction. At the top of the sensor is a bucket and a funnel through which water moves and is counted within the sensor as each water droplet passes through. It also has a lightning sensor, which is able to detect lightning storms, which can be used to identify when and where thunderstorms occurred. When deciding on which crops to plant in a region, its climate must first be considered because plant growth is dependent on precipitation and temperature. In Potchefstroom, the two most important climatic factors are frost and rainfall. Frost because of the low temperatures, of course, in winter, and because Potchefstroom is located within a summer rainfall region. Frost can cause damage to crops by freezing or rupturing their cell walls, and some plants are more resistant to frost than others. For instance, in winter, you can choose to cover plants that are not as resistant to the frost, or you can choose to plant crops that are resistant to the frost, like cabbage and broccoli. As I've mentioned before, Potchefstroom is located within the summer rainfall region within South Africa, with a long-term annual rainfall of between 619 and 659 millimeters. The wettest month on average is July, with an average of 119 millimeters, while the driest month is July, with an average as low as 2 millimeters per annum. For this reason, we plant summer crops during summer and harvest them in winter. Examples of these include sorghum and maize. Thank you so much for your attention and for allowing me to make this video.
Secondly, you have to look at the soil, and I will take us through how do you classify a soil and look at the different soil properties to ensure that your crop will be able to grow in your soil. So after the climate, the soil is the most important factor to consider for when you plan a crop to plant on your fields. The reason is that's part of the natural setting and cannot be changed or altered, but is what is given to you. The issue with looking at the soil is that it all occurs underground, which is really difficult to actually look at and to evaluate for a specific crop. So for that, we have a soil auger, which allows us to look at the soil at depth without too much effort. It's got a nice cutting edge, and if we turn this instrument into the soil, it allows us to take soil out at depth. We pick it up, look at the soil and pack it around or part of the hole, and do this repeatedly to get to the soil at depth. So as you can see, I've augered up to refusal, which is at the deepest that the auger would go, and I packed out the soil starting from the topsoil all the way to the subsoil on this side. One can see that there are distinct horizons, the topsoil, the first subsoil horizon and the deep subsoil horizon on this side. What a soil scientist would do, we describe each horizon and the properties of that horizon. That would include the texture, the structure, the color, if there are mottles, the stoniness, as well as if there is a presence of lime within this specific horizon. Then we'd classify it according to the South African soil classification system. And what we would find is, if we look at the relevant tables, that this soil that we have here is a magudu, which means it's got an orthic topsoil horizon on a red structured subsoil horizon on a saprolite deep subsoil horizon. The effective rooting depth of this soil is around about 800 millimeters up to a meter, and that means it's probably suitable for any crop that you would like to plant on this. This red color indicates that it is freely drained and that you can use it for irrigation. Things to consider is that it's got quite a high clay content, as well as a strongly structured subsoil, which means that strongly rooted crops would do better on this soil than weaker rooted crops. So those are what we need to consider, but the take home is that on this soil we can plant any crop which the climate allows, and we can irrigate it if required. Once you have chosen your crop, and in this case we have chosen maize or mealies as the crop, you need to make sure your cultivation practices are best for that crop. Dr. Linda Muzango will take us through how to choose and how to do your cultivation practices for maize within the Potchefstroom environment.
My name is Linda Mzangwa. I'm going to talk about the cultivation of maize. So the first thing that I'm going to talk about is land preparation. We all know there are various factors that influence the successful establishment of a maize crop, but land preparation is one of the critical stages of the cultivation process. What role does land preparation play in the cultivation of maize? The first one, it provides a conducive environment for root growth. For example, when you have a compacted field, soil tillage is able to break the compact layers, allow for soil aeration, water infiltration, and optimum root penetration. Secondly, it is a first line of weed and pest control that is done by the farmers. For example, in the background here, there's a prepared field with no presence of weeds. Thirdly, it provides a way of incorporating your fertilizers, your organic matter, your compost, your manure. And lastly, it is also a way of applying sustainable practices for the control of soil erosion and also ensuring water infiltration and reducing water evaporation. So what are the various land preparation methods available for maize farmers? Basically, there are two methods, and these two methods, they vary by the degree of soil disturbance or soil stirring. So the first method, which is the most common method, is called the conventional tillage. This conventional tillage is composed of 3 steps. The first step is land clearing, where the farmers remove all the large debris and the shrubs and the trees. The second step is called the primary tillage, and it usually makes use of heavy implements such as your multi-board plow, your disc plow, your chisel plow, and it entails the conversion of the soil for the entire field, and usually the plowing depth is between 15 to 36 centimeters. And then the last step under conventional tillage is the secondary tillage. The primary role of this stage is to make the fine tilth conducive for the seed-soil contact and proper seed germination. And then the other method, which is more sustainable approach, is called conservation tillage. And usually the chief goal for this sustainable method is to ensure carbon sequestration, erosion control, and ensuring good structure of the soil. So there are various conservation tillage methods that are available, but the most common for maize production regions is usually the zero tillage and also the reduced tillage. So with zero tillage, it means that a farmer has to plant or only disturb on the place where they are going to place their seed. And to do that, they make use of no-till planters, and for small-scale farmers, they make use of jab planters. And in this case, the weed control is usually done through herbicide spray prior to planting. And then when it comes to the reduced or minimum tillage, they make use of lighter implements such as your disc harrows. And usually it leaves about 15 to 30% of the residues covering the soil. And just as in the other case, also herbicide is used prior to your planting to control the weeds. I'm going to talk about the planting of maize. And it's critical when one is planning to plant maize to consider the plant population and also the planting depth. So when it comes to the plant population, this is usually dependent on the target yield. And target yield, it is a function of the resources that are available at the farm, the climate, the soil fertility, and also the choice of the cultivar. And when it comes to the Northwest, which is characterized by limited rainfall, the rule of thumb is to plant not more than 28,000 maize plants per hectare under dryland system, though this population can increase when a farmer chooses to irrigate their crop. And then when it comes to the planting depth, this is dependent on the seed size and also the time of planting as well as the soil texture. So when it comes to the seed size, usually we plant deeper when the seed is larger and shallower when the seed is smaller. And also, when it comes to the soil texture, in lighter soils such as sandy soils, it is usually recommended to plant deeper. And in heavier soils such as the clay type, you plant shallower. And when it comes to planting time, usually which is affected by soil temperatures, so in this case, when your soil is colder, you usually have to plant shallower compared to when your soil is warmer. But the rule of thumb, the planting depth of maize range from 5 centimeters to 10 centimeters.
All crops need nutrition, and that relates to fertilization. Dr. Dimakatso Rampisa will show us how to make sure that your crop receives the optimal rate of fertilization for its specific needs.
In this segment, we are going to look at fertilizers. The main focus will be on what is fertilizer, why is fertilizer important, as well as how much of this fertilizer we need to apply in the field. Now, the word fertilizer simply means that any substance that we apply in the field in an effort to supply the growing plant with essential nutrients. I mentioned the word essential nutrients because, similar to human beings that eat food to sustain their bodies, plants also need nutrients for growth and development. Now we have two types of fertilizers. One is organic fertilizer and the second one is inorganic fertilizer. The inorganic fertilizer is usually synthetically produced and it usually contains more concentrated nutrients when compared to the organic fertilizer. Now, the organic fertilizer, on the other hand, is usually sourced from organic material, similar to your animal manure, compost, or plant residue. Now, let's answer this important question of why do we need to apply this fertilizer. I've already answered part of that by saying it supplies the growing plant with nutrients. These nutrients are essentially required for the biochemical processes that happen in a plant. So for a plant, for instance, to do photosynthesis, it needs this nutrients. For the plant to elongate its roots, to form fruits, to produce any type of yield, fertilizer is required because it supplies those nutrients. Now, to answer the important question of how much of this fertilizer do we need to apply, Well, before you do anything, you first need to go out in the field to collect a sample. Now, when you get to the field, you don't just take any part of the field. You need to collect a representative sample, because whatever sample that you collect will represent the entire field. Now, when you get this sample, you then take it to the laboratory for further analytical procedures. Now, to take you through some of these analytical procedures, let's visit the Eco-Analytica, which is a soil and water laboratory based here at the Noordwes-Universiteit in Potchefstroom. So from the field, you come with your sample, usually in a container similar to the one you see here. And then the first thing that you do is to dry out any excess moisture from your sample. We typically do this by placing the sample in an oven to let out all the excess moisture out. When we are done drying, we then take the sample and sieve it through a 2mm sieve just to ensure that the soil is uniform. And then for the two analyses that I mentioned, which is the plant available phosphorus analysis and the exchangeable potassium analysis, you will then weigh out the known amount of soil on a scale in a measuring board similar to the one you see here. So let's start with the Bray-1 method. With the Bray-1 method, we take a known amount of soil, which we collected from the oven, and then we weigh that amount and take the soil to the extraction room. In the extraction room, we then add the Bray-1 solution, which is a mixture of ammonium fluoride and hydrochloric acid. This is a dilute hydrochloric acid. Now this solution, we then add a known volume of the solution into this container, and we shake it for about 40 seconds. Now after shaking for 40 seconds, we then filter our mixture through this filter paper. You then wait for some time for the filtration to happen. Then after filtering the mixture, then the filtrate is now ready for analysis on the EasyChem. Now the EasyChem is simply a spectrophotometer that is automated that measures the concentration of nutrients by looking at the amount of light that the sample can absorb. Now this is usually related to the color that develops on the sample. Let me clear this up. So when you do the Bray-1 method, the filtrate that you get, you mix it with reagents that will form a blue color. And the darker the color, the higher the concentration of phosphorus. So this EasyChem machine, which is a spectrophotometer, is able to quantify the amount of phosphorus based on how concentrated the color of the sample is. Now, after you receive your results from this machine, you will see results similar to what is shown on the screen. Now, on the screen, you can see that we have a calibration curve, which we use to sort of guide the machine to extrapolate the absorbance that it measures with the concentration of phosphorus that it will be contained in the sample. Now that you have your results for the available phosphorus, let's move on to the exchangeable potassium. Now with exchangeable potassium, we also start by weighing a dry, known mass of soil, and then we add ammonium acetate to the sample. This ammonium acetate is buffered at a pH of about 7. And then this ammonium acetate will then displace all the cations that are attached on the soil. So it will not only extract potassium, it will also extract other cations like magnesium, calcium, and sodium. And then we can then quantify the amount from the filtrate. Now, after adding the ammonium acetate, we then set up the bottle to shake on the shaker for about 30 minutes. And then the filtrate is what we take for analysis on an AAS. The AAS stands for Atomic Absorption Spectroscopy.
If you are blessed to have access to water, you can help your crop by using irrigation. That requires optimal irrigation scheduling for your crop and soil-specific situation. So Piso Siobi will show us how to do that.
You are speaking to Piso Siobi from Northwest University. I'm going to speak to you about irrigation. And I'm just going to speak to you about irrigation made easy. The first thing I'm going to want us to know is what is irrigation. According to the dictionary, irrigation is the watering of land by artificial means to foster plant growth. That is irrigation. That is the Merriam-Webster English Dictionary. What is the purpose of irrigation? The Agricultural Research Council in South Africa is saying the purpose of irrigation is to supplement the soil water reserve in order to enable optimal crop production in regions where it would not otherwise be possible because of insufficient rain. Let me make some few comments. The greatest comment that I want to give here is when you are irrigating, make sure that the plant does not short any water during the critical stages. The critical growth stages of a plant are when the plant are flowering or when the plants are developing and growing their fruit, their grain, their tuber, or their bulb. One biggest question we can ask during irrigation is how do we ensure efficient irrigation? The first thing we have to understand in irrigation is the water requirements of a crop. Then we will be able to apply the correct volume of water during irrigation, and that volume of water in the correct place, the place being in a particular depth and also in a particular diameter around the crops. And ultimately the volume will be given at the correct time. What are the water requirements of a crop? The water requirements of a crop can be defined as the evapotranspiration of that crop. That is how much water is being evaporated from the ground and also it is being transpired from the crop itself. And for you to get the evapotranspiration of a crop, you need the reference evapotranspiration of that place where you're going to grow the crop and then get the crop factor of that particular crop. The reference evapotranspiration, if you multiply it with the crop factor, you'll be getting the evapotranspiration of the crop itself. Now, how do we apply the correct volume of water in the correct place? The first thing that we have to know for application of the correct volume is to know the available water capacity of that soil. Available water capacity of a soil is defined by the fill capacity of a soil, the fill capacity being the upper limit of the available water capacity of that soil. And the second value that you have to get for your available water capacity is the permanent wilting point. The permanent wilting point being the lower limit of the available water capacity of that soil. One other thing for the available water capacity that you have to know is the effective rooting depth. The effective rooting depth multiplied by the available water capacity will give you the total available water in a soil, which you will use for the amount of water that has to be applied to that soil. So how do we apply our water at the correct time? Now, applying our water at the correct time, we need to know how much water can we extract from that soil without giving the crop water stress. So usually there's a value we use, we call the percentage allowable water depletion. How much percentage of the water can you withdraw from that soil without stressing the plant? And usually the percentage allowable water depletion is between 50 and 60% for the soils with a low available water capacity. But for a soil with a higher available water capacity, then you can take your allowable water depletion to between 70 and 90%. And let me just make this comment that the percentage allowable water depletion is higher for cooler periods of the year than for the warmer periods of the year. How do we then know how often to irrigate or the correct time to irrigate? So if we are having the total available water, the total available water in the soil, and we know the evapotranspiration of the crop, if we divide the total available water with the evapotranspiration of the crop, we will know what is the frequency. We will know the number of days that will be the frequency of our irrigation. Then the most important thing, what irrigation methods can we use for irrigating? The most commonly methods for irrigation are the static sprinklers. Those are the sprinklers that are fixed to a particular field where you are producing your crops. Or you can have the moving sprinklers, or it could be moving guns or the moving booms. And the other types also are the micro sprinklers, the drip pipes, and the center pivot. The most commonly used center pivot one, even though it's very expensive. The less commonly the less commonly used irrigation methods are the flood irrigation method. And these flood irrigation methods include the furrow irrigation method, the border, and the basin irrigation method. Let me make concluding remarks. For us to know how much, when, and when to irrigate, we can use a spreadsheet. We can also use the water measuring devices. The water measuring devices within, for us to know how much water to irrigate and when to irrigate it and how much to irrigate it, how much of that water to irrigate. We can use the spreadsheets. We can also use soil measuring devices so that we can track the amount of water in the soil and the amount of water that is taken out of the soil. And it's not only about having millimeters of water in the soil, but you can also express those millimeters of water in the soil as cubic meters of water in that soil. Just as an example, you should know that if you are having a millimeter of water in a hectare of soil, you should know that that is an amount of a cubic meter of water in that soil. And a cubic meter of water, it's 1,000 liters of water. So the last remark that I can give is that water, we can apply water to a field of land, and then we can know how much water is being taken out of that field of land. And then from those values, then we can make an irrigation schedule. Thank you.
So thank you all for watching. I hope it has been insightful and interesting, that you would now be able to choose your specific crop for your specific field.